Hi, folks. Welcome back. I hope you're all doing well. For the longest time, people thought that journals are too slow and conferences are where you publish all the cutting edge research, in computer science anyway. But the speed at which ML research and particularly research on LLMs is progressing, even journals, I think, are going to go the way of the dinosaurs pretty soon. I'm finding all these papers on arXiv via mentions on Twitter, and by the time it goes through peer review, ends up at a conference that happens once a year, it's more going to be a record of what worked or what didn't work rather than what's actually cutting edge research. Anyway, with that editorial out of the way, let's look at today's paper. And this one I found pretty exciting because it is a twist on the chain of thought pattern for prompting LLMs, but it adds a new modality. By modality, we mean the kind of input that it takes. So obviously, we've all been prompting LLMs with text, but the new modality that's added in this paper is images. So vision as an additional modality. And the basic idea is that, as you can see in this example over here, that if in addition to the text prompt, you give the LLM an image, and then you can actually extract features from that image, that additional information will allow the LLM to come up with a more detailed rationale or chain of thought, and also get the correct answer more often than it would have with simply text modality. So first, let me quickly explain what chain of thought prompting is. What researchers have found that when prompting an LLM for a task on a reasoning question, a question that involves some kind of logic or steps of reasoning to arrive at a conclusion, so-called chain of thought prompting is much more effective than simply asking it for the answer. And it sounds like a pretty simple thing, but you essentially add this phrase, let's think step by step, to the prompt. And this makes the LLM enumerate the steps that one would take to solve the given problem. And this kind of chain of thought prompting has now become very popular because it gives much better performance on tasks than plain non-chain of thought prompting. So that's the background. The authors in this paper want to enhance chain of thought prompting with images in addition to text. But there is a problem with chain of thought prompting. And the problem is that on small models, which is to say models with less than 1 billion parameters, they tend to hallucinate illogical or incorrect answers. And so we see that chain of thought prompting needs pretty large models like GPT-3, which has 175 billion parameters to get a good hit rate. And that is a problem that the authors here are trying to solve. Their hypothesis was that if you give the LLM images in addition to text as part of the prompt, that additional information will allow it to produce better chain of thought answers. And the way they do it is by incorporating these vision features into the language model. So they're using another model, and this model is called end-to-end object detection with transformers, which is extracting features, computer vision features, out of images. So they use that model, the DETR model, to extract computer vision features, and they use those features with the language representations before giving it to the LLM. There's a lot more detail here, and I definitely encourage you to check out the paper if you're interested in the details, particularly the mathematical details behind it. But let's look at what kind of results this gives them. So first of all, as you can see in this pie graph, the number or the fraction of hallucination mistakes goes down quite a bit. So of a 64% hallucination rate, if you just look at that 64%, of that, they're able to resolve more than 62%. And here is an example which illustrates that Here's a question about magnets along with a picture of the magnets. And the baseline method, which is to say just the textual modality, is not able to quite understand the question and gets the wrong answer, whereas the model enhanced with vision features is able to pick up on the fact that in the image, the north pole of one magnet is close to the south pole of the other one, and that helps it to arrive at the correct answer. So that's the key idea. The key idea is that the additional information in the image is helping the LLM to make more accurate deductions. And here is a table that summarizes their results. They're using a bunch of different models, including good old GPT-3, which is one of the largest ones with 175 billion parameters, and running it through a number of well-known benchmark questions. And then down here, they have the multimodal chain of thought scheme that they're proposing in this paper, and they have a smaller model with about 200 million parameters and a larger one with about 738 million parameters, both of which in comparison to GPT-3 would be considered to be small models. And as you can see over here, even with these small models with less than 1 billion parameters, they are handily beating GPT-3 with chain of thought. So that's the key benefit, that with this additional information, the incorporation of vision features, you're able to get much better results with a smaller model. So that was a quick look at a paper that essentially is trying to teach LLMs how to see, in addition to also understand text, and getting much better results on reasoning problems with smaller models than large models that have not been taught how to see. So that's a really interesting result and definitely something to keep an eye on. I hope you enjoyed that. I'm gonna leave you with another example where, using the hints from the image, the LLM is able to do a much more accurate deduction about the problem. I hope you enjoyed that, and I'll see you next time. Thank you very much.